In this section, we'll look at the concept of an interface. For that, let's create a new file called as interface.sol and start writing as usual. I'm doing it again and again so that this sticks in your mind, right? I'm not doing it in the same contract because readability is more. Also, every concept is abstracted from each other, right? So let's create a contract int, and within this you can say, let's say, some rules for interfaces, right? Now, an interface is like a standard set by someone, right? So for example, we have the ISO standard, we have the ISI standard, we have the financial standards like IFRS, US GAAP, etc. So what they tell you is a set of rules, right? A set of rules like you have to do this, but how you do it is depending upon the company, right? How you do it, who you do it with, what is the method that you follow will be taken care of by the company, right? So IFRS is one standard, but how do they make everything in that format is depending on the company, right? Which means an interface is like a rule set, rule book that is set by some other contract. You will follow those rules, but you will customize it according to your own. You can remember it that way. So the basic rules of an interface is that interface cannot have variables. You cannot say you have to use these variables, right? Then it can inherit. So interfaces can oh sorry interfaces cannot inherit, right? Interfaces cannot inherit another contract into this because interfaces are created in such a way there are only function declarations in that. Okay, then comes interfaces can be inherited, which means interfaces, you can inherit an interface and create a new contract. That is allowed in interfaces, right? Then comes this can only contain function declarations. So remember all of these four rules and you will be able to create an interface. Let me try to create an interface here to show you in real life how this might be implemented, right? So let's say the regulator of a particular country, right, says to all the colleges that you have to record the student names. Okay, whenever they attend a class, whenever they attend a webinar, you should record the student names, right? Now, with this condition, the colleges can choose how they record the names. Okay, so the interface goes like function record name, right? And inside you need to get the name of the student. So I'll say string memory name, and this will be a public function, and I am done, right? So the regulator has set the rule that you have to record the name by getting the name from the user, right? From the website you will enter the student's name and that will be recorded into the blockchain, right? That is the rule set by the regulator, right? Now what you need to do to make this an interface is that you will change this to interface. Remember, abstract contracts have abstract contract as two keywords, right? Here if you are creating an interface, it will just be interface, right? Also there is this error which talks about the visibility, right? So this says functions and interfaces must be declared external. Why is that the case? Because difference between public and external is that public functions can be used within the contract, on derived contracts and the public, right? Now external can be used only by derived contracts and the general public, like externally owned accounts, right? Now is there a possibility that this function record name can be used within the interface itself? No, there can only be function declarations in the interface, and hence you can declare it as external, or you have to declare it as external, right? Go back to the visibility specifier concept and you'll understand why it has to be external, right? Perfect. Now let's say there is a company A, right? Or this should be contract A. Okay, so there is a company A or a college A in our example, right? They want to use this rule and follow the rule. What they do is they are thinking about it and they want to store the names, okay, they want to record the names in an array, right? So remember I told you the rules can be implemented in any way by all the followers of it, right? So here I am saying function record name, right? So I'm getting a string memory name, right? And I want this to be public, okay? Why do I want this to be public? Is because record name can be called by anyone and externally owned account also, right? Now if I want to inherit this interface, only if you inherit an interface you are going to follow the rules, it means, right? So companies which follow IFRS or US GAAP rules, they tell to the public that I am going to use IFRS. Same way this contract A is saying I am going to use this interface, right? So once you use this interface, which means you are using this function within the interface, right? You are writing the same thing and trying to implement it. You have given the rule, I am implementing it, right? In these cases, it should have another keyword called as override. Yeah. So only if you give this override, Solidity will understand that, okay, he is trying to take this function name or the function which is non-declared and trying to implement it, right? So only then this will understand that language, right? So within this function record name, you are gonna implement it. How does this college A wants to implement this? By creating a array. So they are creating a string public students, right? So they create this and here they are saying, you know, students dot push of name, right? So that's it. So the interface wanted you to record all the names. You have recorded the names, right, by using an array and pushing the name into that. Now the college will have a record of all the students who attended it, all the names of the students, right? Perfect. Now come to another college, contract B, right? This is also going to inherit this interface. Now you're gonna say function, right, record name, of course, string. Remember, you cannot change this if you want to follow the rules. The rules are rules, right? So I've created this thing which is also overriding record name. I'm gonna follow the rules but implement it in a different way. How can I do that? I can say a mapping, right? So create a mapping which maps string to, let's say, true, yeah, and then say public, call this students, correct? Oh, not true, it should be boolean, the variable type, right? Okay, now what am I doing? Whenever I get the name of the student, I'm gonna do students of the name is equal to true, which means whenever a name comes, I'm setting this mapping to true, and that is how this college wants to implement this rule, right? So these are the things how interfaces can be created, like rules and contract A, contract B, kind of multiple companies, colleges under the jurisdiction of this entire country who set the rules, or the regulatory body who set the rules, is going to implement it in a different manner, right? So that gives a good explanation for this interfaces, I believe. One thing to note here is that in the previous example of abstract contracts and this example of interfaces, right, we have few new keywords that we gave. Abstract contract means you have to give the keyword called as abstract, and in the function it should be made virtual and all, right? So we saw that here in abstract, right? This keyword, etc. were not existing till 0.5 versions of Solidity. Okay, so if you go to the internet and look at any of the old examples, they might not contain these keywords like abstract and virtual, etc., because it was non-existent in the 0.5 version. Only in the 0.6 versions these rules were introduced, as in whenever you are creating an abstract contract, make it explicit. Whenever you are writing a function declaration within an abstract contract, make it virtual, right? Then in the interface, if you look at, whenever you are inheriting and setting up the rules, writing the same function and implementing it, you have to give the keyword called as override. In the previous version, like 0.5 point whatever, this was not there, right? So that thing I wanted to mention, so that you don't get confused when you go to the internet and search for any sample contracts written by someone in the 0.5 version of Solidity. Yeah. So whenever you are looking for it, probably if possible get the latest version or 0.6, right, in this case. Otherwise you need to look at the differences, understand the differences between 0.5 and 0.6 before you can go through any examples online, right? So keep in mind when you go through some existing examples or predefined examples that were written. Some would have been written in 0.4 also. In 0.4 we do not have the concept of pure and view and etc. We had only constant, right? So these are a few differences, major changes between versions of Solidity, right? 0.4 to 5 to 6. Any person who has been following 0.4, 5, 6, etc. like me would know the differences of how to write these things. But for a new person learning Solidity now, it's better to learn the new version, but also remember that the previous versions do not contain these things, the major changes between the previous versions and this, right? So that's one thing I wanted to mention at this point in time, because we have a lot of things that is new in the abstract contract space and the interfaces space, right? Perfect then. So I hope this example gave you a good understanding of interface. Let's see in the next section.